Hello, Dr. Mitra. We developed a project that deals with the time series analysis of the data of current trending cryptocurrency, which is nothing but the Bitcoin. The project title is Bitcoin Price Prediction. So these are the project files that consist of all the data and the execution code. Here it is in the data folder. It consists of the database, which is nothing but the Excel file, data set for the machine learning model. And here it is the model, and this is the architecture diagram of the project, how the work is going, the work of the diagram. This is the document which is prepared in IEEE format, and this is the main file which consists of the main code of the project. And this is the results section which we'll be going to see throughout the video. The tools that are used to execute this project are Jupyter Lab. This is the package from the Anaconda Python. So I have launched Anaconda Python and launched the Jupyter Notebook. Here it is the main file that consists of the main code of the dataset. The dataset which is being implemented in this file. So let's see, we can see all types of. This is the data set that consists of the data Bitcoin price analysis from year 2014 to 2022. So here it is the starting date where the data set starts, and it goes through the different days, and what is the high price and low price, and which is the closing price for that day. So the Bitcoin has different kinds of environments, and it is adapted in the business as well as the cryptocurrency as well. So here is the data set that is downloaded from the let's see, from the Yahoo website. We can see here it is the website. We have downloaded the dataset from the Yahoo Finance. So here it displays every day what is the open price and what is the closing price and what is the amount of exact at the particular time. This we have downloaded this file and implemented data analysis and the modeling on this file. So let's see what is the main code of the project. We have used LSTM. LSTM is a artificial neural network algorithm that stands for long short-term memory algorithm. So it is a artificial recurrent neural network algorithm which shows the short-term memory. It has a short-term memory, but it stays a long data of time series analysis. So this algorithm is best for the data which is fluctuating day by day. Like the price of the land, price of the house in a popular city, or in a metropolitan city, or it may be useful for the Bitcoin as we use it in this project. So Bitcoin price is fluctuated from day to day in the market. So we have used LSTM. We have suggested LSTM as a good algorithm that predicts the actual price of the Bitcoin. So here it is the architecture of the LSTM algorithm. This is the cell states and this is the hidden states. So it works with the help of the neural networks. Here it is the input through the algorithm, and here it is the output that is given by the algorithm. So we have imported required libraries that will be suitable for our project, and we have downloaded the dataset. As I said, the dataset is downloaded from the Yahoo Finance, and we loaded the dataset into the main df variable, and we have it has the 2713 rows and 7 with different variables. Let's see. The data is date, and the different fields are open, high, low, close, adjusted value. And this is the tail end of the data set. This is the complete description of the data set. And here it is the exploratory data analysis, means the performing data analysis on the provided data set. So the data set is not exactly suitable for the prediction, because the data set may consist of the not a numbers, the null values or the double values. So we must perform explore data analysis on a data set before going to the machine learning model. So here in this project, the analysis is performed on different years. The dataset consists of 14 to 22. Among around 7 years data. So we have performed analysis on each year individually. So here we removed the adjacent clause and the value from the dataset, and the remaining fields are this. The dataset look like after removing those two fields. And these are the open and closing values of a particular month the Bitcoin price of the particular month. So, but in the data set, the remaining month data has not been saved. So it is displaying only these months. Let's see the graphical representation of the data, closing price and open price. Here the maximum closing price and the Bitcoin high price and Bitcoin low price for the month of the respective month for the respective year. This is the Bitcoin analysis chart for the Bitcoin price, open price, close price, and high low values. This may be used in later in this project. So same as we did for the 2015 and 2016, 2017 and 2018, 19, 20, 21, 22. So the Bitcoin price varies year to year in a drastic change. So let's see here for this year. Let's consider this is for year 2018. So in 2018, in January, the price may be high, but when comes to the end, the Bitcoin value is slightly decreased. The Bitcoin open price, close price, high value, and low value is slightly decreased due to the market trends. So it has a drastic effect in the market. Bitcoin has, so that's why it is drastically decreased into year 2019. Let's see in 2019 from January to June, the first half of the month, it is moderately increased, but after that it maintains a consistent rate, nearly consistent. So in 2019, the drastic change will appear after 2020. So this is the analysis chart for 2019. Let's say about 2020. So in 2020, it maintains a slightly constant rate up to the end of the month, but in last 2 years, it is increased value. We have seen increased value in the Bitcoin price. Next. This is analysis chart for the year 2020. This is slightly increased when end of the year. This is for 2021. In 2021 also it maintains a slightly high rate and low rate in according to the situation upon the market trends. In 2022, let's see, this is a new data. It has only up to February in 2022, so it stands a high range of Bitcoin price. Let's see different let's see overall assumption, overall analysis from 2014 to 2022. Before this, before going to the modeling, all these experimental data analysis is mandatory to know how these trends are recurring year to year and how these fluctuations are maintaining year to year. This is the overall analysis of the open, close, high, and low price from the year 2015 to 2022. So the Bitcoin price value is increasing from year to year, and up to 2020, it is in the low value, but after 2020, after COVID, it is increased and slightly maintaining a high range. Now, building the machine learning model takes the input as a database data set, which is nothing but the Excel file, and it the results give the if in case of it is a classification model, then it gives the different labels as the output. If it's the regression model, then it gives the different it's a performance is measured on different evaluation metrics. Let's see from the slides. This is the architecture of the project. So here the Bitcoin data set, because we downloaded from the final set. So the data set, we perform our EDA, exploratory data analysis on those data sets. So data set we are making the data is suitable for the algorithm. So the algorithm may detect detect any kind of irregularities in the data set or randomness in the data set. So here, after performing exploratory data analysis, we are normalizing the data set. Why here normalization means? So the Bitcoin has a very when considered from 2014 to 2022, the we see a low value of the price in 2014, but it may be higher in 2022. So to manipulate these changes, these price changes, we have to normalize the data. So normalization is nothing but the removing subtracting the minimum value of the Bitcoin for that month from each and every day values. So it attains a random value. So this is nothing but the normalization. So after doing normalization, we are splitting data into test set and training data set. Then the model LSTM is trained with the example data and tested with the test data provided by us. So after prediction, we will displaying visual graphs as well as the we are for classification. It is directly we measure accuracy, but in the regression for the regression model, we must we don't have any accuracy, but we measure the performance with the help of the performance metrics. Let's see what are those performance metrics. Here, this is the normalization of data. So normalization is a technique so that is used to maintain a random value among the different fluctuating values. So here we are considering we are dividing the training set and the testing set. So in the ratio of 60 and 40. And we are this is a time series data, so we are maintaining a regular intervals of time. I mean, let's here we take let's 15 days of time, so it will repeat for every 15 days. And this is the actual model building code, and from the Python scikit-learn library, we have imported this sequential method, and this we given input as the training set and testing set to the LSTM model, and it displays the validation and the plotting loss and the validation loss. So validation loss is nothing but the how much of the error is occurred while predicting the values for the respective data. So here it is the training loss, the red color line is, and the blue color line is the validation loss. So here we see some kind of fluctuation in the graph. So here this is the validation loss. This is the error we got while predicting. So the model evaluation can be done with the evaluation metrics like RMSE, MSE, and FSE. So the full forms are root mean square evaluation metric and mean square evaluation metric and mean absolute error. So these are the standard values that can be generated by the algorithm. And we also checked the regression value. So we know that the regression value always lies between 0 and 1. So here it is 0.956 something and 0.96 something. So the model predicted the for the next step that should be it is the right one. And this is the R square score for regression. This is also lies between 0 and 1. R square is for the regression models only. And this is a comparison of Bitcoin close price and predicted close price. Yes, we predicted for the next 30 days. So here, this is the old red color line is the 60% of data that we have given to the model for training. And this blue color line is green color line is the tested by the algorithm. So this is matched with the actual values of the data. So the model predicted correctly. And this is prediction for the next 30 days, and these 30 days are not in the database. So we are just giving for predicting for the next 30 days. So this is the last 15 days fluctuating value, and this is the next 30 days. So the next 30 days, the Bitcoin price will increase slightly in a gradual state. So till now, we have divided the training set and testing set into 60 and 40%. But here we are maintaining 80% and 20%. So 80% of data is given to the training set and 20% is for the testing. So now the fluctuations may vary because the training data is included and testing data is decreased. Let's see it in the graph. So here we see, so there is no validation loss in this. So the training and validation loss is fluctuating above, and the validation loss is fluctuating below. So there is no intersection between these two trends. So that if we increase the training data, then the model will be given accurate data, accurate predictions. This is the complete project execution, and this is the compare between the original close price and the predicted close price. See here, this red line represents the 80% of training data, and this green color line trend represents the 20% tested data. So it is exactly matched with the blue color line. This is nothing but the original closing price. And this is all about the project. And here we let's see, we see different price analysis of the Bitcoin from year to year, and we have predicted next 30 days how the price may vary with the help of the previous year's data. And again, we have given only 60%, 40% testing data. And this is one case. And another case is we have taken 80% and 20% training, 80% training data and 20% testing data. So in both cases, we have measured we have seen how the trends is going to display in how the trends are looking like. So we have captured all these screenshots and pasted in a document. And here it is the IEEE document for this prediction of the Bitcoin price using LSTM model. And this is the IEEE document. We have screenshot. We have took screenshots of the different code snippets and placed it in the documents also for clear understanding. Okay, thank you.